We have pushed the single agent paradigm to its absolute breaking point. If you want to build AI that actually survives production, you do not need a smarter model. You need a completely new operating system. For the last 2 years, the industry has been obsessed with teaching models to write code, answer questions, and take actions. But a model is just a calculator. It is a raw, probabilistic engine. It does not inherently know how to run a business process, manage a long-running task, or recover from a sudden failure. To do any of that, you need robust architecture. You need an Agentic OS. Look at the evolutionary timeline of artificial intelligence. First, we had prompts. You type a static string into a text box, the machine predicts the next tokens, and the interaction dies right there. It is completely stateless. It is a wind-up toy. You pull back the cog, it moves forward 3 feet, and it stops dead. Then we discovered loops. We wrap the model in a basic script that feeds its own output back into itself. We give it memory, give it tools, and suddenly it can execute multi-step tasks. That is an agent. For builders, this was the first leap toward real software automation, turning a chatbot into a proactive worker. A single agent in a loop feels like absolute magic. It researches, writes code, and triggers external actions. But that magic is incredibly fragile. It is a high-wire act without a safety net. Imagine building a customer support agent that successfully refunds a user 10 times, but on the 11th try, it hallucinates a database drop command. This is the phase of the industry where we had a single hero agent doing everything. We assumed that giving the model more tools and more autonomy would naturally scale our productivity. But a hero agent is a contradiction. A single operator juggling 10 complex APIs, a massive context window, and a strict set of business instructions is a system built entirely on luck. It is a lone chef trying to cook a 5-course meal for 100 people, inevitably burning the main course while chopping the dessert. The shift we are facing right now is recognizing that the heroic single agent is a dead end. To build reliable software, we have to move from isolated loops to structured, collaborative systems. Why does the single agent architecture absolutely shatter when you try to scale it? Because every time you add a new tool, every time you increase the autonomy, you multiply the surface area for failure. When an agent takes 10 sequential steps to achieve a goal, a small 1% error rate in the model does not stay contained. It compounds with every single decision point. It is a leaky pipe inside your wall. One drop of hallucination rots the entire floorboards over time. One bad hallucination, one misformatted JSON payload, or one slightly misread error log poisons the entire run. The context window gets polluted with garbage, and the agent confidently spirals out of control. For builders, this means you cannot ship features that rely on deep, multi-step logic without expecting catastrophic, unpredictable failures in production. Engineers call this cascading failure. The agent is still running, burning compute and consuming your tokens, but it is achieving absolutely nothing. It is just confidently hallucinating its own demise. You cannot predict when this will happen. LLMs are fundamentally non-deterministic. You can run the exact same prompt twice and get a perfectly working script one day, and a completely broken API call the next. It is a slot machine masquerading as a microservice. Heroic agents do not scale. They accumulate risk. They become massive liabilities in production environments. The solution is not to beg the model to be smarter. The solution is to change the architecture entirely. To build AI that survives reality, you need an operating system. In the same way Windows or Linux schedules CPU threads and manages memory for your traditional software, an Agentic OS manages your autonomous workflows. This OS is a comprehensive orchestration layer. It sits above the raw models, taking responsibility for routing tasks, managing shared memory, enforcing permissions, and handling the distribution of tools. It is a traffic control tower, ensuring no single agent collides with another or wanders out of its designated airspace. Instead of relying on a single soloist trying to do everything, the OS runs a relay team. You deploy specialized agents with strict boundaries. A planner agent breaks down the complex logic. For builders, this isolation is crucial. It means a single broken tool does not corrupt the master project plan. The OS then hands those discrete steps to the executor agents. They are highly optimized, possessing only the specific tools required to write the code or query the database. Nothing more. Imagine a surgical theater. The anesthesiologist does not hold the scalpel. Finally, a critic agent evaluates the output against your strict business logic. The OS coordinates this handoff seamlessly. This division of labor is the only way to trap complexity before it spreads. By isolating these roles, the OS ensures that a failure in the executor does not destroy the entire project plan. The orchestration layer is what turns a fragile chain into a resilient network. But even a team of agents will fail if they operate without a harness. You cannot scale what you cannot verify. Blindly trusting an autonomous system is how you leak data and break production environments. The harness is a strict test, evaluation, and gating layer that sits wrapped around every single agent action. It is the safety mechanism. It forces structured outputs, meaning the agent cannot just spout random text. It is a sieve, catching the good logic and mechanically filtering out the hallucinated noise. It requires replayable traces. Every thought, every tool call, and every token generated is permanently logged. You can rewind a specific execution, see exactly what the model was thinking, and debug it objectively. Most importantly, the harness enforces strict quality gates. Before an agent is allowed to ship code, send an email, or modify a database, it must pass programmatic and model-driven verification checks. For builders, this means you can finally guarantee deterministic outcomes from non-deterministic models. This is what turns absolute autonomy from a massive liability into pure leverage. The harness is the uncompromising difference between a system that merely looks done and a system that is actually done. Without a sound harness, you are just giving a hallucination machine the keys to your infrastructure. The harness grounds the agents, keeping them chained to reality and accountable to your business rules. Even with perfect orchestration and a bulletproof harness, systems degrade. APIs rate limit, cloud providers drop connections, and high-end reasoning models hit unexpected latency spikes. A production-grade Agentic OS must never freeze when a single part of the chain fails. It must gracefully degrade. Perfection is a myth. Resilience is the actual goal. The system must keep moving. Think of an urban power grid. If one substation goes down, the automated grid does not shut off the entire city. It instantly reroutes power through secondary lines, keeping the lights on while the primary node is repaired. In an Agentic OS, every single role is electable and handoff-able. If the primary planning agent fails to return a valid schema in time, the OS seamlessly elects a backup model to take over the exact context. For builders, this means your application stays online even when your vendor is experiencing a meltdown. If a heavy reasoning model is overloaded, the OS falls back to a faster, lighter model for that specific step and retries with strict verification. This is how you build a system that bends but never actually breaks. This is AetherLink's golden rule for sovereign AI. No single component, no single model, and no single human is indispensable. The system routes around damage, and it survives. Let us bring the architecture together. Scaling AI that actually works in the real world requires a very specific trinity of engineering principles. The first element is the orchestration layer. Orchestration replaces the heroic solo agent with a coordinated relay team of specialists. It breaks monolithic tasks into safe, isolated, and manageable execution boundaries, protecting your business logic from cascading errors. The second element is the sound harness. This is the uncompromising verification layer that gates every action, enforces structured outputs, and guarantees the work is actually done, not just confidently hallucinated. And the third element is graceful degradation, the fundamental guarantee that when pieces of your system inevitably fail, the OS instantly reroutes, falls back, and keeps moving forward without freezing. Orchestration, the sound harness, and graceful degradation. That specific trinity is how you transform a fragile, probabilistic model into a production-grade, autonomous engine for your business. This is exactly what we are building at AetherLink. As a sovereign AI studio, we design these agentic systems specifically for engineers and founders who cannot afford hallucinations, fragile loops, or vendor lock-in. If you are done playing with fragile prompts and are ready to deploy real, resilient agentic architectures in your own stack, the blueprints are waiting. Visit the channel, subscribe to the briefing, and let us build the future.